Hello students, today's discussion on module 3, 8051 IO ports and programming. IO stands for input or output. When we look at the pin diagram, we have already discussed regarding the pin configuration, and we know that it is a 40 pin dual inline package DIP IC. Equal number of pins are shared both sides. 20 pins are available this side, 20 pins are available on the other side. And we know that each pin has got a special functionality designated. Regarding that, it has got 4 ports, namely port 0, port 1, port 2 and port 3. Apart from that, it requires some common signals like VCC, ground, then crystal frequency, reset signal. These are the other than port signal. In this particular chapter or module, we are going to mainly focus on the ports. Why the ports are required, how many pins are dedicated for that, and how it can be used, how we can program. Let's look at the brief introduction of the port. We know that it has got 4 8-bit IO ports, namely port 0, port 1, port 2 and port 3. Each uses 8 pins. All the ports upon reset are configured as input. Very important information. Here, when it is configured as, or when we press a reset button, immediately by default it will be an input configuration. That means you can connect any keypad or any switches to that. So it will receive the information from external world to the internal microcontroller, ready to be used as an input port. If I want to configure it as output port, I have to send 0 to that to make it as an output port. To make it as a reconfigure it as an input port, again I have to send 1 to the each port. Let's look in detail how we can do that. So I have tried to capture all the information regarding IO ports, maximum information being projected in this table. Let's look into the each detail. Starting from the ports, we know that we have got 4 ports and each ports are 8 pins. The naming of each ports or pin, starting from P port 0.0, this is the first pin of port 0 to port 0.7. That's the last pin of a port 0. So it has got 8 pins. Similarly for port 1, port 2 and port 3. And when we look at the hardware configuration, in the hardware configuration, very important to drive the external devices, we require a pull up resistor. Especially in the port 0, it doesn't consisting of a pull-up resistor. Built-in pull-up resistor is not available. It has to be connected externally. But rest of the port 1, port 2 and port 3 are built-in pull-up resistors. You need not to connect for that. Regarding this hardware connection, next slide we'll talk about this. Next, what is the role of this port? Is it having a single role or dual role? Yes, this particular port 0 having a 2 roles. One is I can use it for input or output port, or I can connect any external memory also to this. Then whenever we go for external memory, the whole 16-bit address has to be accessed. The data need to be transferred. Then I have to use the port 0, which is having a dedicated operation for that. If it is connected as external memory. If not connected, then I can use this port 0 for any input or output devices. But port 1 has a dedicated purpose that is called IO ports only. I can use it any input or output devices connection. Then rest 2 has got multiple functions as in the port 0. Port 2 also got a similar functionality like port 0. It can be used as a simple or common IO port or external memory. Whenever we go for external memory interface, then this has to be dedicated for that operation. So port 0 and port 2 must be reserved whenever we go for external memory interface. If not, I can use it as a general IO port. Then port 3 has got a multiple functionalities. Along with that, IO ports are a serial communication interrupt timer. All you can see here. So you can observe here RxT and TXT are the two reserved for serial communication. This is for interrupt, this is for timer, and this is for control signal. All these has got a multiple functionality. So that's what I have mentioned here. Then upon reset, all the ports are configured as input. Please keep it in your mind. So that means by default, it works as an input. If you want to configure it as output, then accordingly 0 must be sent to the each pin. Then it can work as a output port. Then what are the pin numbers? By looking at the pin details, you can observe there 32nd pin to 39th pins are reserved for port 0. Similarly, for port 1 and port 2 and port 3. Then if I want to access through this SFR, special function register, what is the address associated with the particular port? And this table, especially this column, gives you the byte access address. If I want to access using a move instruction, then directly I can use this address to move a data to the port, or I can access the data from the port using this column address. Each respective port 0 address is 80H, port 1 98, similarly for port 3 it's B0H. You should know the address to access the particular port, or directly you can use the name like P1, P2 as a mnemonic to access the individual port. If suppose I want to access a single bit rather than the whole 8-bit, then there is again provision is given to address in a bit addressable manner. If I want to access the D0 bit of a port 0, that is P0 of 0, then the unique address is given to that also. Then this I can use it for a bit manipulation operation like set bit, clear bit, jump no bit. Many of the instructions are available to manipulate particular bits. Similarly, I can access individual bits also, or the whole byte can be accessed using this address. So this is all about the complete summarize of the ports. Let's look at the hardware details also. As I said, the port 0 requires a pull-up resistors. It doesn't consist of an internal pull-up resistor. You can observe this. Each pin does look like this. Each pin internally has a MOSFET connected to that. So this this is open. So this must be connected to the 10 kilo ohm resistor. Each pin must be connected to the 10 kilo ohm resistor connected to the VCC. Then it works. Then I can connect to any external devices. It can be used for input or output. Each pin must be connected externally to a 10 kilo ohm pull-up resistor. This is due to the fact that port 0 is an open drain. This particular diagram you can observe, this drain terminal is open, it's floating, it is not connected yet. So this has to be connected to any pull-up resistor, then you can operate. But unlike port 1, port 2 and port 3 are built in actually. So as I already said, port 3 has the additional function of providing some extremely important signals. These two are dedicated for serial communication, these two are for external interrupts, and these two for timers, and this is for reading and writing external signals. Now let's look at the coding part. We have seen how it can be operated and what is the hardware connection. What are the pins dedicated for that? Does it have a single role or dual role? All we have seen. Now let's look at how the ports can be operated as an output port. There are three methods can be followed. Say the task is the following code will continuously send out to a port 1 the alternative values 55H and AAH. 55H and AH means alternative output LEDs will glow accordingly. So now a conventional method. First look at the conventional method where the 55 data is moved to the accumulator. Then accumulator data is directly moved to the port 1. This makes a particular LEDs, alternative LEDs to glow. We know the 55 equivalent binary value is 0, 1, 0, 1, 0, 1, 0, 1. Similarly, after calling a delay, we are creating a delay to notice the changes happened in the toggling. So that's why we are calling a delay here. And when we call the next, when we move the AA data to the accumulator, that means 10, 10, 10, 10, 0. This is the alternate LEDs will be glown. Similarly, this will be moved to the P1. Similarly, we are calling a call delay again to find out the toggling. Then SJump back. We are repeating this process continuously. See, this is the one conventional method or normal method we can say, moving to the accumulator, then passing the accumulator content to the port 1. Here, in an efficient manner, they mentioned it as an efficient manner where we are skipping the data movement to the accumulator. Directly the data is moved to the particular port. The another method is little more easier. Only once data is moved, then this data is complemented here. So there are three methods can be used which does the same task, continuously sending out the port 1 alternating values 55 and AA, which does the same task, all the three programs. You can use any one of the programs to simulate it. Next, how to make the port as an input port. Prior to that, directly sending the information to the respective ports will serve the purpose. But here, in order to make port 0 an input, the port must be programmed by writing 1 to all the bits. If port 0 I want to configure it as an input port, then first instruction must be this. I have to pass FF to the accumulator, then accumulator data is passed to the port 0. This two instruction makes the port 0 as an input port now. Now you can connect any switches to this particular port and you can observe whether the data being received or not. So in order to check whether the data is received or not, what are we doing is, and then data is received from the port and sent to the port 1. We are checking whether the data being received, is it acting as an input using these two instructions. So then I am going to use port 0. Port 0 is this, which is the input. Whatever the switches status will be moved to the accumulator. Then this directly moves to the port 1. If port 1 is connected with the LEDs, now I can find out through the switches what is the status. Whether I have pressed it as 0 or 1, that will be clearly reflected in the port 1. So in this way, the port 0 is configured as the input port by using these two instructions, and port 1 directly we are sending the port 0 information. That makes this is the output port. Let's look at the simulation part. So for this, I have brought here Proteus software. I have already connected. You can see here. This is 8089C51. This is a microcontroller I am having here. And to operate this, I am applying a 12 megahertz crystal frequency, 12 megahertz crystal frequency, and this is a capacitor is required, which acts as a crystal oscillator. So it generates a sustained oscillation, and reset must be connected to the VCC as well as it should be connected to the external access. That means we are not going for any external access. Okay, and here for port 2 and port 1. So I am in this program, in this simulation, what I am doing is port 2 is dedicated for the output operation and port 1 is dedicated for the input operation. I am connecting a SPST single pole double throw SPDT switches here. You can observe the components I have used here. So I am using 8089C1, this component, capacitor here, and crystal oscillator here, LED blue. This alternative LEDs are blue LEDs, and subsequent the next LEDs are here red LEDs. You can observe here later when I simulate it, you can find out which is the blue LED, which is red LED. Now if I want to simulate this, it's a very easy, it's an open source also, you can download it and you can observe yourself how it works. And you require one more software, it is called Keel Microvision software. Let's try to simulate this program. The first program to make port as an output port. So this is the program where it consisting of a 55 data and AA data is passed to the port 2, and I am calling it a delay between that to generate, to notice the changes, the toggling of the LEDs. Let's see, to simulate that I have to first assemble it, compile it, then I have to generate a hexa file which is generated mod3 here. Let me go to the Proteus and double click here, and you can find the path where I have to locate. mod3.hexa file is my file. It's already generated in this MC8051. I am locating it here. Okay. Click OK. Now it's installed now. The software is installed. Now you can run this particular microcontroller to see whether your microcontroller port 2 is acting as an output port. I have already configured here. You can see here port 2 is used to showcase the output port. Let's look into the simulation part. When I simulate this, you can observe here changes. When blue LEDs are glowing, red LEDs are off. When red LEDs are on, blue LEDs are off. In this way, the simultaneously blue and red LEDs are glowing. So in this way, the port 2 is acting as an output port. A simple way to understand. Similarly, I can halt this temporarily. Now, if I want to see how to make the port as an input port, I have written a code here. Let me copy here. Let me replace the code. This especially, I am making port 1 as an input port by this 2 instructions. Let's bifurcate this. These 2 instructions serve that we are making the port 1 as an input. I have already connected the switches to the port 1 here. You can observe the port 1 is used to showcase the input of an action. Now, here the port 1 information is sent to the accumulator, then accumulator information is sent to the port 2. That means port 2 is an output port. Let's look at the compilation part of that. Yes, I have compiled it and have created the hexa file also. I am going for Proteus here. It's already downloaded here. Path is installed. Okay. Now, whenever I apply any value here, that will be reflected at this here. So the status of the switches will be reflected. That means this acts as an input port. Immediately, that will be circulated to the output port. Let's look into the details. When I simulate this, as we know by default, the port acts as an input port, and here now if I want to change the end of the signal, since port 1 is connected to the VCC, this is already sent to this particular. In this way, it is on. Okay. Look at here, the port 1 is connected to the VCC. Similarly, this is connected to the VCC. So rest of the ports also connected to the VCC. In this way, all the LEDs are glowing. Now, if I change here, if I connect it to the ground, look at here, I am changing the status of the switch, and meanwhile, you can observe it is changing. The port 1 of 0 is directly affecting to the port 2 of 0. This is connected here. You can observe here, when I make the changes at this particular point, when it is grounded, it is off. Similarly, the port 1 of 1, if I change here, that will be reflected as port 2 of 1. You can observe here, it's off now. When I release it, it's on. It's a red LED. Similarly, for next one, the status is reflected. So the last one. That means this particular port is configured as the input port by using these two instructions. Then immediately the data which is available in the port 1, the status is moved to the accumulator. Then accumulator content is moved to the this port 2. With the help of a simple few instructions, we have seen both how to configure it as an output port and how to configure it as an input port. In this way, you can simulate yourself. Thanks for watching the video.